Download this code from codegive.com, link in the description below. OK, let's dive into static type checking with Mypy as presented at the Swiss Python Summit 2022, along with a code example and detailed explanation. While I don't have a recording or transcript of that specific talk, I can reconstruct the common topics and approaches covered in similar presentations on Mypy from that period. This tutorial will cover 1. Introduction to static typing and its benefits. 2. What is Mypy? 3. Setting up Mypy, installation and configuration. 4. Basic type annotations. 5. Advanced type annotations. 6. Using Mypy in your workflow. 7. Dealing with errors and exceptions. 8. Practical code example. 9. Gradual typing strategies. 10. Dealing with external libraries. 11. Troubleshooting and best practices. 12. Mypy and linter/formatters. 13. Resources for further learning. 1. Introduction to static typing and its benefits. Traditionally, Python is a dynamically typed language. This means that the type of a variable is checked at runtime, not during the compilation or earlier stages of development. While this provides flexibility, it can also lead to errors that only surface when the code is executed, potentially causing unexpected behavior in production. Benefits of static typing ****. Early error detection ** catches type-related errors before runtime, reducing the likelihood of bugs in production. Improved code readability ** type annotations clarify the intended purpose and expected data types of variables, function arguments, and return values. This makes the code easier to understand and maintain. Enhanced code maintainability * easier to refactor and modify code when type information is readily available. Type checkers help identify potential ripple effects of changes. Better code completion and IDE support IDEs can leverage type annotations to provide more accurate code completion suggestions, inline error highlighting, and refactoring tools. Increased confidence static type checking provides more confidence in the correctness of the code, especially for large and complex projects. Performance potential. Although not a primary goal, static type checking can, in some cases, enable optimizations by the Python interpreter. 2. What is Mypy? Mypy is a static type checker for Python. It allows you to add type annotations to your Python code and then use Mypy to verify that the code adheres to these type annotations. It is not a compiler, it doesn't change how your Python code is executed. It is a tool that analyzes your code statically, without running it. Mypy makes use of the type hints introduced in Python 3.5, refined with PEP 484, PEP 526, PEP 544, PEP 589, PEP 591, PEP 604, PEP 612, PEP 613, PEP 673, PEP 675, PEP 692, PEP 695, PEP 702, PEP 705, PEP 735, and others. 3. Setting up Mypy, installation and configuration. Installation configuration, optional, but recommended. Create a mypy.ini or pyproject.toml file in the root directory of your project. This file allows you to configure mypy's behavior. Example mypy.ini*. Example pyproject.toml*. Common configuration options ***Python_version, specifies the Python version your code is targeting. ***Strict, enables all strictness options. This is generally recommended for new projects. Asterisk ignore underscore missing underscore imports, whether to ignore imports that cannot be resolved. Asterisk disallow underscore untyped underscore defs, require type annotations for function definitions. Asterisk disallow underscore incomplete underscore defs, require type annotations even if the function body is missing. Asterisk check underscore untyped underscore defs, type check function bodies without annotations. Asterisk warn underscore return underscore any, warn about returning any from a function. Asterisk warn underscore unused underscore ignores, warn about unused type, ignore comments. Asterisk plugins, allows you to specify plugins for Mypy, example for Django, pedantic. 4. Basic type annotations. Let's start with basic type annotations. These are used to specify the expected types of variables, function arguments, and return values. Asterisk name, str, specifies that the name argument of the greet function should be a string. Asterisk dash str, specifies that the greet function should return a string. Asterisk age, int, specifies that the variable age should be an integer. Asterisk data, list int, specifies that data is a list of integers. Note the use of generic types. 5. Advanced type annotations. Python's type system allows for more complex annotations using the typing module. Asterisk list tuple str, int, a list of tuples, where each tuple contains a string and an integer. Asterisk dict str, int, a dictionary where keys are strings and values are integers. Asterisk union int, str, a type that can be either an integer or a string. Asterisk optional union int, str, a type that can be either an integer, a string, or none. Equivalent to union int, str, none. Asterisk callable int, a callable, example of function, that takes an integer as input and returns an integer. Callable arg1 underscore type, arg2 underscore type, return underscore type is the general form. Asterisk any, represents a completely unconstrained type. Avoid using any if possible, as it defeats the purpose of static type checking. Use more specific types when you can. Asterisk literal, used to specify that a variable or function argument must be one of a specific set of literal values. Asterisk type var, used for creating generic types. This is very useful in classes. Asterisk new type, can be used to create distinct types from existing types. Asterisk protocol, used to define duck types, structures for static duck typing. 6. Using Mypy in your workflow. 1. Run Mypy asterisk from the command line, navigate to the directory containing your Python files and run. 2. Interpret the output asterisk Mypy will report any type errors it finds. The output will typically include the file name, line number, and a description of the error. 3. Fix errors asterisk carefully review the errors reported by Mypy and modify your code to resolve the type issues. This might involve adding or correcting type annotations, changing the types of variables, or adjusting function signatures. 4. Integrate with your IDE asterisk most popular IDEs, VS Code, PyCharm, etc. Have Mypy plugins or extensions that provide real-time type checking as you write code. Configure your IDE to use Mypy for a smoother development experience. 5. Integrate with CI/CD asterisk include Mypy in your continuous integration, CI, pipeline to automatically check for type errors whenever code is pushed. This helps prevent type-related bugs from making their way into production. 7. Dealing with errors and exceptions. Mypy helps you catch type-related errors. Here's how to handle them and exceptions in general. Mypy doesn't directly check the logic of exceptions, example that y might be 0. It focuses on the types. The return type annotation -float means that all possible return values must be floats, or convertible to floats. Returning float, INF, is okay because float, INF, is a float. Returning none would be an error unless the return type was optional float or union float, none. 8. Practical code example. Let's create a slightly more involved example. Imagine you are building a simple e-commerce system. 1. Run mypy *mypy your_file.py. 2. Review output * correct any type errors mypy finds. For example, if you accidentally passed an integer to add _item instead of a product, mypy would report an error. 9. Gradual typing strategies. It's usually best to adopt static typing incrementally. Here's a common approach. 1. Start with core modules * begin by adding type annotations to the most critical modules in your code base. 2. Bottom up or top down *. Bottom up, type the lowest level modules first, then work your way up the dependency chain. This is often easier because you can more easily define the types of basic functions. * top down, type the highest level modules first. This helps clarify the overall architecture of the system. 3. Use type, ignore sparingly * sometimes. You might encounter situations where mypy reports an error that you cannot immediately resolve. In such cases, you can use the type, ignore comment to suppress the error. However, use this sparingly and add a comment explaining why the ignore is necessary. You should aim to remove these ignores as soon as possible. Mypy's warn _unused _ignores equals true option will help you find any ignores that are no longer needed. 4. Stubs.py files. If you are using a third-party library that doesn't have type annotations, you can create stub files, .py, that provide type information for the library. The TypeShed project provides stubs for many popular libraries. 5. Consider reveal _type, *. You can use reveal _type, variable, mypy specific, to ask mypy to infer and print the type of a variable at a particular point in your code. This is extremely helpful when debugging type issues or understanding how mypy is interpreting your code. Remove these when done debugging. 10. Dealing with external libraries. External libraries can be a challenge if they don't provide type hints. Here are some strategies. 1. TypeShed * check if the library has type stubs in the TypeShed repository, https://github.com/python/typeshed, https://github.com/python/typeshed. TypeShed is a collection of external type annotations for Python libraries. Pip install types. Your library may install useful type stubs. 2. Inline type annotations *. If stubs are not available, you can add inline type annotations using type, ignore comments to suppress errors related to untyped libraries. 3. Create stubs *. You can create your own .py stub files to provide type information for the library. This is a more involved approach, but it can be beneficial if you use the library extensively. 4. Use cast, sparingly *. If you are sure about the type of a value returned by an untyped library, you can use typing.cast, to tell mypy what the type is. But be very careful, as cast bypasses type checking. 11. Troubleshooting and best practices. Read error messages carefully. Mypy's error messages are often quite informative. Take the time to understand what the error is telling you. Asterisk simplify the code. Asterisk if you are struggling to understand a type error, try simplifying the code to isolate the problem. Asterisk use a debugger. Asterisk if necessary, use a debugger to step through the code and examine the types of variables at runtime. Asterisk consult the Mypy documentation. Asterisk the Mypy documentation is a valuable resource for understanding the type system and how to use Mypy effectively. http://mypy.readthedocs.io/ http://mypy.readthedocs.io. Asterisk be consistent. Asterisk adhere to a consistent coding style and use type annotations consistently throughout your code base. Asterisk use meaningful names. Asterisk use descriptive names for variables and functions to improve code readability and make it easier to understand the types. Asterisk test your code. Asterisk static type checking is not a substitute for testing. Write unit tests to verify that your code behaves as expected at runtime. 12. Mypy and linter/formatters. Mypy works well with other tools. Asterisk linters, example pylint, Flake 8 use linters to enforce coding style and best practices. Some linters can also check for type-related issues. You can configure your linter to work alongside Mypy. Asterisk formatters, example black, AutoPep 8 use formatters to automatically format your code to adhere to a consistent style. Asterisk pre-commit hooks. Asterisk use pre-commit hooks to run Mypy, linters, and formatters automatically before each commit. This helps ensure that your code is always in good shape. 13. Resources for further learning. Asterisk Mypy documentation. Asterisk http://mypy.readthedocs.io/ http://mypy.readthedocs.io. Asterisk pep 484, type hints https://peps.python.org/pep0484/ https://peps.python.org/pep-pep-0484. Asterisk pep 526, variable annotations https://peps.python.org/pep0526/ https://peps.python.org/pep-pep-0526. Asterisk type shed repository. Asterisk https://github.com/python/typeshed, https://github.com/python/typeshed. Asterisk real Python's Mypy tutorial. Asterisk https://realpython.com/python type checking/ https://realpython.com/python-type-checking. This tutorial provides a comprehensive overview of static type checking with Mypy. By following these guidelines and practicing with code examples, you can effectively leverage Mypy to improve the quality, maintainability, and reliability of your Python code. Remember to adopt gradual typing strategies, integrate Mypy into your workflow, and consult the documentation and other resources when needed. Good luck, and happy typing!